Good morning, my dear students. So again, third experiment I'm going to conduct today in this PPT. Okay, so name is undamped torsional vibration. So here in the previous first two experiment, what we completed means with that with oil we are going to plot the vibration. Okay, so here we are going to not using any oil to plot the vibration on a graph sheet. Okay, so name of the experiment is undamped torsional vibration. Okay, so undamped nothing but we are not using any oil. Okay, without oil, just to remember that. Okay, torsional vibration nothing but normally the vibe here the in a when a system or in a body when a particle is rotated that is around the axis of the shaft is called as a torsional vibration. Okay, so here we are going to use a string and oscillation takes place in a horizontal direction. These 3 points you have to remember to conduct this experiment. Okay, so here the aim of the experiment is to determine the angular frequency, logarithm decrement, frequency, time period, damping factor of a string mass damper system. Okay, that is under underdamped torsional vibration. Okay, so here the apparatus is the same. The apparatus torsional vibration string without damper. Okay, so here where the damper is, we are going to use oil, but here we are not using any damper, so we are going to consider in the apparatus as string without a damper. Okay, so same. This is about the diagram. Same diagram will be there. So this is about it consists of a one drum, one sketch pen, one direction of the vibration. Okay, disc that we are going to give the twisting movement in a without oil. Okay, so after just giving the twisting movement, you are going to get what the vibration on a graph sheet. From graph sheet, you are going to consider the xt value. After getting the xt value, you are going to solve the given quantities in the question. That is in the aim. Okay, so here the procedure is there very simple. So fix the graph sheet on the drum without any wrinkle. Okay, take the graph sheet, go on fix to the that drum around the drum. Okay, so once it is fixed the graph sheet, then now you are going to check what fix the pen or pen holder and make sure that it is touching to the graph sheet. Okay, so now switch on the motor. Once you switch on the motor, just to give the twist to the disc that is in a horizontal direction. So when after giving the twist, then automatically a vibration plot will be plotted, that is undamped vibration will be plotted on a graph sheet. From that you are going to note down the values from x1, x2 and xt value. Okay, and from that you are going to calculate what natural frequency. So okay, so these are the observations they given in the question, that is the drum diameter d is equal to 75 mm and motor speed is equal to 6 rpm, that is 0.1 rotation per second. Okay, these are the formula we are going to use to solve these equations. Okay, so result normally you can going to write the result as usual for undamped torsional vibration. Once you calculate those values, just to write here. Okay, so this is about the what undamped torsional vibration. In the second session I'm going to tell you on the how to take this, how to we are going to plot the vibration on a graph sheet. Okay, so now listen carefully on the demo, that is video. So once you listening that video, then you are going to calculate these values. Okay, so now we are going to move on to the that is the second session, that is video. Okay, how to conduct this experiment. Good morning, my dear students. So, in the after that listening that PPT, so now I came to the experiment that is undamped torsional vibration. Okay, so here we are going to draw again the vibration plot. That is undamped torsional vibration plot on a graph sheet. Okay, so here the lab setup is what, that is the aim of the experiment is what, to determine the natural frequency, logarithm decrement, time period of a undamped torsional vibration. Okay, so here also the lab that is about the aim. So apparatus you required is this is called as a string. Okay, so this is called as a drum, sketch pen, and the motor is required for you. Okay, so this is about the apparatus. Okay, so next how we are going to conduct this experiment is again similar procedure. So in the previous case, in the damped torsional vibration, we are going to use the oil. Okay, that oil is called as a SAE oil 6. Okay, so here in the undamped torsional vibration, so we are going to we are not using any oil. Okay, so without using oil, we are going to plot, that is what we are going to plot the vibration graph, that is vibration. So on this graph. Okay, so now I am going to tell you the procedure. Procedure is same what you did in the first experiment. Okay, so take the graph sheet. Okay, so the aim of the name of the experiment is undamped torsional vibration. So here we are not going to use any oil to draw the vibration plot in undamped system, that you keep it in mind. Okay, so now take the graph sheet, again same procedure you follow. Okay, so you fix this graph sheet to the drum. Okay, around this what you take the graph sheet, fix the around the drum. Okay, exact middle center, don't make either right hand side direct, right hand or left hand side. Okay, so you fix the lab properly. Okay, so once you fix the properly, here sketch pen is also there. So here sketch pen should be touches to the this graph sheet. Okay, exactly center. Okay, so with the help of this take any, it should be exact middle one. Okay, so once you fix the graph sheet on the drum, take use tape or something, so you fix this loosely. Okay, so once you fix this, okay, and see that this is very important, that your sketch pen should be, that is your pen should be touches to the graph. Okay, so this is very important. Okay, okay, so you are okay, after fixing this, so you again say procedure, you you switch on the motor. So once you switch on the motor, that will be rotated. Okay, so once you switch on this motor, so you remove this sketch pen. Okay, so you cap of the, okay, okay, once you switch on this motor, the sketch pen should be gone on complete one cycle. Okay, so this is about what the undamped torsional vibration frequency. Okay, once one round is over, then you do the twisting moment to this. Okay, once if you do the testing moment, then you are going to get what here, vibration. Okay, vibration cone. So just to do the twisting moment here. Once we see the vibration here, so once we do the twisting moment, this is about the vibration of occurring in the without oil. Okay, so once you occur, once you got, just to stop the motor. Okay, okay, now you remove the this, if you close this sketch. Okay, so once you fix this, remove the this what
graph sheet.
Remove the graph sheet. Okay, once you remove the graph sheet, so what you draw, this is about your calculation part. Okay, so calculating from the graph, you are going to get what, vibration. This is the vibration graph of undamped torsional vibration. Okay, so from graph again you are going to get what, so you consider any one cycle. Okay, so where it is started, so this is about graph, means you can take the one complete one cycle. Okay, so this is about the time period. So for one complete cycle, and top one is x1, x2. Okay, so this calculation is required for solving the your calculation part. Okay, so first cycle is x1, top one is x2. Take the one complete cycle, xt, to take the centimeter, convert it into meter, and use the calculation part 2, that is to find the angular displacement, frequency, logarithm decrement. Okay, time period. So this is about the undamped torsional vibration. Okay, so I hope you understand this. So just only the difference is, so here with oil and without oil you are going to use. Okay, so damped torsional vibration you are going to use oil, that is called as SAE oil. So undamped torsional vibration means you are not using any oil. Okay, so this that is left hand side setup is you are going to use what, spring. So right hand side you are going to use what, spring. That is the only difference. Okay, so keep it in mind. Now I hope you understand this, how to take the reading from this experiment. Okay, thank you. Okay, good morning my dear students. So after seeing that how we are going to plot out the graph sheet in the video, so now we are going to do the calculation. Okay, so take the graph sheet. Again, this is the nature of graph, so you can consider one complete one cycle. That cycle is considered as xt. Okay, so that value you can note down. Okay, xt is equal to either in centimeter or meter. Okay, so second one is, that is a half cycle is considered as a x1, and top you consider as a another half cycle considered as a x2, that is called as a maximum amplitude. Okay, so once you calculate the graph sheet from x1 xt, then you are going to calculate this what, time period. Okay, so time period formula is equal to t is equal to x of t into 10 divided by pi into d. So here just to substitute from the graph, you are going to get this 43 value, that is in centimeter, and 4.3 is equal to meter. Okay, so 44.3 into 2 divided by pi into 75, so you are going to get what, t is equal to 1.82 second. That is about the time period. Once you calculate the time period, then automatically you are going to calculate what, frequency. Frequency is equal to what, the time, the reciprocal of time period. Okay, so we calculate the time period, that is 1.82. okay, just to substitute here, so you are going to get what, frequency is equal to 0.549 hertz. Okay, so once you calculate the frequency, then automatically you are going to calculate this what, natural frequency. Okay, natural frequency formula is equal to omega n is equal to 2 pi f. Okay, just to substitute the f value in this equation, you are going to get what, natural frequency is equal to 3.43 radian per second. That is called, it is denoted by omega n. Okay, so once you calculate this omega n, just to write in the result sheet also. Okay, all these values. Okay, so time period t is equal to 1.82. okay, frequency is equal to 0.549, so natural frequency is equal to 3.43. this is about the result. Okay, in the result column you note down this. So this is about the what, damped torsional vibration. Okay, so here just to remember that the difference between damped longitudinal and torsional nothing but in the torsional we are going to use the string, and in the damped we are going to use what, the spring mass damper system. Okay, so this is about the undamped torsional, that is a torsional vibration. Okay, I hope you understand this experiment. So okay, thank you.